Okay, hello everyone. So my name is Zoltan and I work for IdomSoft company. So in the next 20 minutes I will introduce and I will present how we use observability and AI in air governance ecosystem. So few words about us. So IdomSoft is an indirect state-owned company. We are playing a role in development, integration, installation and operating IT systems in a national significance. So our users are the citizens, so we are providing them services. We have the client gate with more than 3,000 governance cases. We have an electronic customer service portal with more than 5 million users and about 4 million electronic personal identification. And we also provide services to the local government. And in addition that, we have the national data asset, which consists of 7 registers for supports administrative records and related procedures. And annually, we also support elections, votes in a national level. And also we have developed central governmental service bus called KKSB for data interoperability. So we have more than 200 connected organizations and in average 60 million requests per month. For the development, we have a public application development environments for unifying the development in the public administration. And for that, we have the public application catalog for information about the development. But why we need an efficient operations? As you may realize, we have a lot of services, and taking into account the age and the type of the technology, we have very old systems, and we have the cloud native applications as well. So our goal is to make the operation efficient, make the faster and more efficient error handling, increase the availability and reliability of the services, and then we want to benefit for the service operation by reducing the number of incidents, and in the end also we want to help the work of the application development. But how? So we want to use, we are using open source as we can. So the important is there is no license limitation, no additional cost. It has a fast development cycle, and there is a wide user community. But there is a trade-off as well. There are disadvantages, which means there is no customized support. Public code base in our cases can be a problem, and lack of the documentation and also the qualities of the documentation is depending on the open source solution. And how we can improve the observability. So we use anomaly detection and other methods like root cause analysis and APM, analyzing the APM data, forecasting service map. So we are in the observability session, but I would like to somehow define what it is. So the notion of the observability was introduced by a Hungarian-American engineer called Rudolf Kalman in 1960 in the paper on the general theory of control system for controlling linear dynamics system. So in software environment, so in the distributed system, observability is the availability to collect data about program executions, internal states of the module, and the communication between components. So if you check the Wikipedia, there are a lot of definitions, but I would say the now definition is just how we understand what's happening in our system. So we introduced observability because the monitoring is not enough in a complex heterogeneous computing environment, and in addition we started to use AIOps machine learning techniques as well. But how we process the data. So we have to challenge, there are a lot of products and a lot of microservices, and we need a unified monitoring data structure in order to analyze that data, and we have also different data sources. So we are connecting data from legacy system and the cloud-based Kubernetes-based platforms, and we also will collect data from mobile and web applications. So after that, we process the data, and we store the data in a central place, and then analyze and visualize that data. So in the picture right side, you can see how the production system is built. So we are collecting data, the traces and matrices with OpenTelemetry, and we use OpenTelemetry collector and data prepare to process the data, and OpenSearch to store the data. So for the logs, we are using Fluentd and Logstash for transforming, parsing the logs and storing in OpenSearch as well. Grafana, OpenSearch dashboard for the visualization, and Jupyter Labs for analysis. So this is only for application monitoring, but we are using Prometheus, Nagios, Itzinga for other type of monitoring, such as infrastructure monitoring. So for the data ingestion and processing, so we are using OpenTelemetry for metrics and traces, as I mentioned before. As you already may know, that it's a collection of tools, APIs, and SDKs for analyzing software performance and behavior. So why we decided to use OpenTelemetry? So we decided to use OpenTelemetry because it's a vendor agnostic. The same agent can collect telemetry data, which means our data pipelines is much simplified. And there are various receiver, processor, and exporters. And also, there are also possible to use a processor for cost optimization to reduce number of data stored in storage. For instrumentation, we are using auto-instrumentation where we can, but sometimes that doesn't work, for example, in the Node.js cases. And then currently we have the agent instrumented using Helm, but we are moving to the OpenTelemetry Kubernetes operator. And the second part is collecting logs. So we are using Fluentd, which is a cross-platform log collector, collecting application logs and the system logs as well, where the Kubernetes is running. For the Kubernetes, we will move to Fluentd, and we keep Fluentd in the legacy system for collecting logs. So for the data processing, we use the collector for process the metrics and traces, and data prepare for processing OpenTelemetry data and inserting to the OpenSearch. And for the data storage and analysis, so we are using OpenSearch, which is a real-time distributed search engine, which performs very well in time-series data. And one of the good things, you can store logs, traces, matrices in a single backend, and it has a lot of functionalities like trace analytics for visualizing OpenTelemetry data, event analytics, which provide SQL, PPL, DSL, query languages, and it supports Prometheus as well. And there is also security analytics plugin for SIM functions, and there is machine learning, built-in machine learning plugin as well. In the figure, you can see analyzing the event analytics panel, analyzing a specific error message. In that figure, you can see a trace with where span and the trace analytics dashboard. As I mentioned before, we are using Grafana and OpenSearch dashboard for data visualization, and for the application alerting, we are using the built-in OpenSearch alerting plugin, and we group together the same type of error messages, and we send to a dedicated email address. And now I will talk about how we use machine learning algorithms to analyzing the data. So we have developed OpenPandas data frame-based analysis and manipulation framework for analyzing data stored in open source. It's high domain-specific knowledge of open source, so it provides data exploration, data transformation, and visualization, and it can be integrated any Python-based analytics platforms at scale. You can see in the screenshot a very simple example of how you can use OpenPandas, and then we use OpenPandas for analyzing the data. And now let's talk about anomaly detection. But before, what is an anomaly? It's an abnormal situation, unexpected event. But you may know it's not easy to decide what is the normal and what is the abnormal. You need a lot of information. If you look at the picture, you can see a plane landed on a highway. So it's not a normal situation. The anomaly have different types. There is a point anomaly. So let's say we have 10 cars and one plane, so it means something wrong, so we can see an anomaly. And the point anomaly is very simple to detect, because you have, let's say, a data point and it's different to the other. And the contextual anomaly, you need the context, like in the figure, you have to see the cars and you have to see the environment what's going on. And then the collective anomaly, so if all flights are cancelled in the same region, and if you have data only from one plane or two, you don't know it is anomaly. You need all the information to decide this is the anomaly. So there are a lot of algorithms. They are machine learning algorithms. I called classical or statistical based algorithm like KNN, PCA, and neural network based algorithm. We compared the classical and the neural networks performances. So as you can see in the right figure, the neural networks learning time is much higher than the the classical algorithm, but the accuracy is of the neural network is much better than compared to the classical algorithm. So we have developed a convolutional autoencoder. It's a neural network. You can see the architecture of the autoencoder in the bottom of the slide. So our case is we have the input time series, and then the encoder transforms the time series into a meaningful latent space Z, and then the decoder reconstructs this compressed representation of this time series through the minimization of the cost function. The convolutional autoencoder, it's encode input data by splitting the data into the subsection and then converting this subsection into simple signals that are summed together to create new representation of the data. So here a very simple example about anomaly detection. So we use this convolutional autoencoder. We train as an unsupervised way because there are a lot of data points and it's not easy to annotate all the data points. So then we decided to train the neural network different patterns, and then when it's needed, we go to a supervised way. So in the figure, you can see there is a sudden increase of requests, which status is 200, and then this pattern didn't show to the network, and then it means it was not able to reconstruct that time series. You can see where is the sudden increase happened, then the reconstruction loss of this time series is higher than a certain level. In our case is 1. But what happens if some organization 1 year want to get some data, some information in our system? So it's not an anomaly. Then we have to say, okay, somehow next time, if next year this happens again, it should not again an anomaly. So then we use Grafana and we label the data. So the 0 means we don't know about the time region, it's an anomaly or no, we don't know nothing about that region. We say -1 where it's not anomaly, and 1 the region that is anomaly. And after continued training, you can see in the last plot, the region where it was above the red line, it's now above and almost the same as the other data. It means there is no anomaly. And in summary, so monitoring is not enough. So observability in a heterogeneous computing environment is a must. OpenTelemetry is very good to unify the data pipeline and process data. Observability can be improved using AIOps, especially anomaly detection in a complex environment. So in the end, I would like to thank to PASMA and Peter Catholic University for the collaboration and the support of the Hungarian National Laboratory, and thank you also for the attention.
Thank you again, Zoltan. Any questions? Just raise your hand if you have any questions. Oh, yeah, okay.
So every time you have a new kind of anomaly, you have to do a new supervised training and label it, and then and then you also have to hope that whatever you label as an anomaly is also strong enough for the next time that it comes up.
Yes. Every time, this is It's required because there is a lot of data point. We cannot start with someone to label what is the normal. So we start with the unsupervised, and then we move to next.
Any other questions? Oh, yeah, go for it.
So do you have this pipeline running continuously all day long, or do you just sometimes execute it?
So could you please? Cannot hear very well.
Sorry. Do you have this pipeline running continuously all day long, or do you just sometimes run that to see, hey, in the last week, did we have any anomalies? Like, is this?
No, it's offline.
Okay.
It's not yet, but we are planning to put it to the pipeline there to not manual.
Cool. Okay. That sounds good.
Cool. Anyone else? In that case, thank you, Zoltan.
Okay.
Yeah, we will meet again in 6 minutes for the next talk. Thank you.